Okay guys, we're going to look at finding the center of rotation on shapes, primarily when it's either 90 degree rotation, 270 degree rotation, or 180 degree rotation. Okay. First basics of the rotation. I'm using GeoGebra for this. It's quite easy to see on there, and we'll go over just a few key parts of rotation to start with. We've got the direction of rotation, so if we're talking a clockwise rotation, it goes in the same way as the clock does, hence the name. Okay, and it goes round to the right. Alright, and we've got three things that we need to know. Wherever we put the image, or the copy, if you like, of the object is my original, the image is the copy of it. So wherever we put it, if we put it here, okay, it tells us that it's been rotated clockwise in the direction of the arrow going around there. It's gone clockwise a turn of 240 degrees in this case. Alright, so it's a measured turn around the point 1 1. Okay, so my coordinate would be 1 1. So we need to know three things. We need to know the direction, we need to know the degree of turn, how much we've turned it, and around which point. So in this case it's around the point 1 1. Okay, if I rotate that back there, if I move my center of rotation, you can see it still rotates the same, but it will be on a smaller arc. If my center of rotation, the nearer it gets to the shape, okay, the smaller the distance away from my center of rotation. Okay, if we look at this one here, again, if I rotate this round, it rotates on a lot wider arc. Okay, so in this case my rotation would be from -2 1. It's still clockwise, still going clockwise, and if we put that at 90 degrees, okay, you can see the shape itself it's slightly more difficult to see that it's been 90 degrees because the original shape is on the diagonal. Okay, if that was a horizontal or vertical shape, it would be more easy to see how much of a turn it is. So as soon as they start putting things on diagonals, it becomes a little bit more difficult. Okay, so okay, so looking at this, I've got some shapes that I've drawn on here. Okay, so we're going to look at the two triangles for a start. This triangle is the original, and then this is the copy. This has been rotated. You can see that point B has rotated to the top, point A has rotated to the top. Okay, and what you can see is if I rotate this shape 90 degrees, I'm just going to imagine I pick the shape up and I turn it 90 degrees around the point B. My A would rotate 90 degrees clockwise, and it would rotate up to here. Okay, my C would rotate from this point 90 degrees clockwise, and it would rotate to here. So you can see my shape would then rotate to that point. Okay, so we can see this isn't a 90 degree rotation, so let's go another 90 degrees. So this is going to rotate 90 degrees down to here. This is going to rotate 90 degrees down to here, and you can see this is the shape that I've got. So straight away, just from doing that, I can see that that's a 180 degree rotation. And if it is a 180 degree rotation, what you're able to do, okay, is you are able to link up each of the points, B with B, C with C dash, and A with A dash. So A dash, B dash, C dash. And you can see in the middle there, where the points intersect, that is my center of rotation at the point 2 2. Okay, so this particular shape has had a 180 degree rotation around the point 2 2. Now in this case, for a 180 degree rotation, it doesn't matter whether it has gone clockwise or anti-clockwise, okay, because it is exactly the same. It'll be in exactly the same place. If I rotate 180 degrees, whether it be clockwise or anti-clockwise, it would still stay in the same place. Okay. Right, let's look at these two rectangles. Again, you can see hopefully if I turned that 90 degrees, I turned this one a quarter turn, it would be more like that. It's not going to fit in the same footprint. So if I turn it another 90 degrees, it would fit in exactly the same footprint. My F is going to go to the top, my G is going to go to the top, and so on. Okay, so again I'm going to connect up the by line sectors. I'm going to connect so E to E dash, F to F dash, D to D dash, and G to G dash. And again you can see in the center point there we've got the point of rotation, center point of rotation. So it's rotated 180 degrees around the point -8, 10. So along a corridor first, and again if I try and just raise it up a little bit so you can see the axes, we've gone -8 along and 10 up. Okay, final shape. Okay, so if we've got this shape here now, because this isn't, again we're on the diagonal, so it's difficult to see any rotation. Okay, imagine we're going to pick up the original shape and we're just going to turn it. Which way will we turn it to make it orientate the right way? Okay, now on this one hopefully you would see I'm either going to turn it anti-clockwise. I'm going to turn it backwards. I'm going to turn it this way, so that this point is here and this point has to drop down to get to here. So this is going to go this way to get to here. Okay, so let's join up again some of these. We know it's not 180 degrees. I'm not turning it upside down, so I can't just join up all of the lines because it won't match up. Okay, but what I can join up is I can join two sectors. I can join L to L dash, and I can join J to J dash. It doesn't matter which two you join up, but you only need to join two together. Once you've joined two together, we're going to do a perpendicular bisector on each of these lines. Now normally you would use in an exam you would use a set of compasses to draw two arcs at the just over the halfway point, and draw two arcs, and where they intersect we would draw a perpendicular bisector. In this case I'm just going to draw in the two perpendicular bisectors, and that means that this has cut this line in half. Between there is cut the distance between the 2 points exactly in half at an angle of 90 degrees. That's what perpendicular means, at an angle of 90 degrees. I do the same on line N here, and you can see where this line and this line intersect at that point there. That is my center of rotation. So if I got a piece of tracing paper, I would draw this shape round, put my pen on there, and then I would rotate it round to here. If I'm thinking what if I had to describe this, it's rotating anti-clockwise, and it would rotate 90 degrees. That's a 90-degree turn, and the point of center of rotation is -5, -10. So it's rotating around that point. So those three things I would need to know. Okay. Last thing I just want to show you is we've got two shapes. Again, we can see that they're not 180 degrees. This has just been rotated. It's been rotated up there. So my D has gone up with C. So I've gone anti-clockwise again. I've gone a quarter turn. I've gone 90 degrees. So it's 90 degrees anti-clockwise to get from my object to my image. Okay, now we just need to find the center of rotation. Now in an exam, if you were sitting the exam and you had to show how you'd find that, this is how you would do it. Pick 2 points. Now in this case I've picked B and B dash, so we're talking this point and this point. Set the compass to the width of just over halfway between the 2 points. So we've gone just over halfway, and I've drawn a circle around each of the points. Where the 2 circles cross, where they overlap, you draw a line. Okay. So in an exam situation, 2 arcs where the 2 points cross, draw a straight line. Okay. Going to the next 2 points, I'm going to use D, this point here and this point here, D and D dash. Again, draw 2 circles around it. You only need the 2 parts where they intersect here. Okay, you don't need to draw whole circles, but if it helps, you can. Okay, and then again we're going to draw a line that intersects those, and where the 2 lines cross, that's my center of rotation. Okay. So we're looking to find the 2 center lines that have perpendicular bisectors, and that will lead me to the center of rotation. Okay. So with the other circles on, there's a circle around B, a circle around B. Here's a circle around A, and a circle around A. Where the circles intersect and overlap, draw 2 straight lines, and where they cross, that's my answer. Okay. Check out my video on using tracing paper to find the center of rotation. Okay, and I've also done a worked example using a ruler if you haven't got a set of compasses, to be able to just use the ruler and still be able to get a 90-degree perpendicular line. Thank you.